to our YouTube channel, Best Science Brain. If you haven't subscribed to the channel, try to subscribe, and then you can also share our videos and invite friends to subscribe to the channel and learn something new every day. Today we're going to look at the topic in physics, which is meant for those in high school or senior secondary school SS3. We're looking at the conversion of galvanometer or millimeter into an ammeter. Galvanometer is an instrument, a very sensitive instrument, which can measure very small amount of current. While millimeter can also measure a small amount of current, but much bigger than that of the galvanometer. The ammeter is an instrument that measures a large amount of current. So we can convert either a galvanometer or we can make it measure a large amount of current by some technical processes. If you pass large amount of current into a galvanometer without doing the conversion, the current will burn the wires off and render it useless. So to convert a galvanometer into an ammeter, we connect it in parallel. We connect it to a low resistance wire in parallel. For instance, this is the galvanometer. We connect it to a wire of low resistance parallel to it. So that is it. To convert a galvanometer into an ammeter, we convert it to a low resistance wire. And that low resistance wire is called a shunt. A wire of low resistance is called a shunt. So we have to complete a circuit. So let the current that we want to measure be I coming into the circuit. The current the galvanometer will collect from this big current to very small. Let's call the current of the galvanometer IG, small g. Current, it may be 10 amperes, and the galvanometer is collecting only 0.01 from it. That becomes the IG. Then let the resistance of the galvanometer be RG. Then, on reaching this point, the current will break into two. Part of it will move into the galvanometer. The remaining part will now deviate. And then the remaining part will now become I minus IG. And this current, that is, subtract the current that takes away from the one that's entering, that have I minus IG. And this is equivalent to IS, which means the current taken by the shunt. Then let the resistance of the shunt be called RS. Repeat the illustration again. To convert a galvanometer into an ammeter, make it to measure high amount of current, we need to connect the galvanometer in parallel to a low resistance wire called a shunt. Let the resistance of the internal resistance of the galvanometer be called RG. R stands for resistance and G stands for galvanometer. Let the current that is entering the circuit, which we want to measure, be I, be a high amount of current. I will know that this current cannot spark directly into the galvanometer without destroying it. So galvanometer being very sensitive will only take a small amount of current, which we call IG. Perhaps you are passing 10 amperes and it is taking about 10 milliamperes, which is 0.01 amperes. Then the remaining current will now be the difference between this and that. We need to now call IS, which is the current that will be taken by the shunt, IS, obtained by this. And from our knowledge in physics, we know that when two instruments are connected in parallel, they carry a different amount of current, but they have the same potential difference across them. So let's call this point A, call this point B, call this point C, call this point D. So these instruments, these two are in parallel. Different current will pass through them, IG for this and IS for this. But they'll have the same potential difference. So we'll now say the potential difference across AB, that's across the galvanometer, will be equal to the potential difference across the shunt, which is CD. Then, or we can say VG equal to VS, where G stands for the galvanometer and S stands for the shunt. We know that BD, again by Ohm's law, as current times resistance. We can now write in place of VG, IGRG, which is stand for potential difference across the galvanometer, equal to ISRS, which is the PD across the shunt, which is VS. Now, making the resistance of the shunt the subject of the formula, RL becomes IGRG all over IS. IGRG is the voltage across the galvanometer, while IS is the current across the shunt. And this IS, of course, is something as from here, the main current minus the current I minus the current entering the galvanometer. So with this, you can evaluate resistance of the shunt. So when you want to solve problems that involve conversion of a galvanometer or a millimeter into an ammeter, think of using the voltage or the PD across the galvanometer equal to the PD across the shunt. PD across the with the Ohm's law, V is IR. So IGRG will represent VG. When I become IS, RL will represent the voltage across the shunt. Then make your RL the subject, or make the one you're looking for the subject, and then calculate other as well. So having done that, we're now going to look at conversion of a galvanometer or voltmeter into a voltmeter. So these instruments, although they are sensitive, but they are special, that you can convert them to an ammeter, you can still convert them to a voltmeter. An ammeter measures large amount of current, while a voltmeter measures potential difference. So this is a very special breakthrough in physics. We are converting an instrument that measures current to an instrument that measures potential difference. Now, when we want to convert, as I said earlier on, when we want to convert a galvanometer or millimeter into an ammeter, you connect it in parallel to a low resistance wire known as a shunt. But when you want to convert this instrument, galvanometer or millimeter, into a voltmeter to measure potential difference, you connect it in series to a high resistance wire, not low resistance this way around, to a high resistance wire known as a multiplier. So let's look at the circuit diagram. So let this be the galvanometer. We want to convert it to a voltmeter. We'll connect it in series on a straight line to a high resistance wire known as a multiplier. So let's represent multiplier using M. So let's complete our circuit. We'll have this, then we'll have that. So current enters from this angle. Let the current be I. And the current enters, this current will be too high for the galvanometer to take. The galvanometer will now take maybe current of IG, which should be the small amount of current. Then let's divide here into two and create a potential difference across the two junctions. Then the current, the millimeter will still take a current IM. But the current the millimeter will take, the multiplier will take a current IM, where M stands for the multiplier. But the current the multiplier will take is something as IG. They'll be equal. Why would they be equal to each other? Because we said earlier on in our video that when instruments are in series, the same current will pass through them. So the current that will pass through the galvanometer is the same current that passes through the multiplier. Then let the PD across the galvanometer be equal to VG. Let the PD across the multiplier be equal to VM. So the total PD from this end, let me call this end A, to this end B, will now become V, which the voltage want to adopt, which want to measure. So this total PD will now be equal to VG plus VM. So our V from A to B now becomes VG with the voltage across the galvanometer plus the voltage across the multiplier. Then from here we know that our voltage or potential difference is IG at current time resistance. Current of the galvanometer time resistance across it, and resistance of the wire. Then for the multiplier, the potential difference is IG times RM. Remember, as I said, the two will have the same amount of current because they are connected in series. So no need using IM. Can you see as we use the same IG, since the two currents are equal. Now from here, we can make our resistance of the multiplier, the subject of the formula. By crossing, we now have voltage measured minus IGRG equal to IGRM. We will now make Rm the subject. Resistance of the multiplier will now become V minus Ig all over Ig. So what have we learned here? We have learned how to convert a galvanometer into an ammeter. To do that, we connect it to a low resistance wire in parallel to it called a shunt. And then to convert a galvanometer into a voltmeter, we connect it to a high resistance wire in series with it. That high resistance wire is called a multiplier. We'll now take some questions to illustrate this. A galvanometer has a resistance of 2.5 ohms and gives a full-scale deflection of 0 to 10 milliampere current. How can it be modified to 1. Act as an ammeter reading 2 amperes. II act as a voltmeter reading 5 volts. So let's start with the first problem. The first number 1. How can we change the galvanometer to act as an ammeter reading 2 amperes? What we do is we connect the galvanometer to a low resistance wire in parallel with it, which is called a shunt, which I described earlier on, a shunt. So, having done that, the current entering here is a current of, we want to read a current of 2 amperes coming from a big current. Then, on reaching this point, the current is split into the current measured by the galvanometer, and then the remaining current will be the current going to the shunt. And we are told that the galvanometer gives a full-scale deflection of 0 to 10 milliampere. What it means is that the highest current the instrument can measure is 10 milliampere. Forget the 0 that is there. 10 milliampere. You convert this 10 milliampere to ampere by dividing by 1000, and that will give us 0.01 ampere. So that means the galvanometer is taking only 0.01 ampere from the 2 ampere current you want to read. Then the current of the shunt, which we say is going to be the main current minus that of the galvanometer, which is going to be 2 minus 0.01, that will give us 1.99 ampere. Then we are looking for the resistance of the shunt, so the low resistance wire. To solve this problem, we'll call here A, C, D. Then we know that since they are in parallel, the voltage across the galvanometer is equal to the voltage across the shunt. When instruments are in parallel, we always say that they will have the same potential difference. When I have IGRG equal to ISRS, looking for RS. RS now becomes IGRG all over current of the shunt IS. So the current of the galvanometer is 0.01. Resistance of the galvanometer should be given to us, what is it? Is 2.5, should be 2.5 ohms. So multiply by 2.5 ohms. All over resistance current passing through the shunt, which is the difference between 2 and 0.01, which is 1.99. Solving this, the resistance of the shunt is going to be, is obtained as 0.126. 0.126 ohm. So it's a low resistance. That proves the fact that you want to convert a galvanometer into an ammeter, you want to measure a high amount of current, you need a low resistance wire called a shunt, SHUNT, connected in parallel to the galvanometer. So low resistance 0.126 ohm is what's required here. Then Going to number 2 question says, number 2 says, how will you make the galvanometer to act as a voltmeter? I've got reading 5 volts. You want the galvanometer to act as a voltmeter, what do? We connect the galvanometer to a high resistance, connect it in series to a high resistance wire known as the multiplier. A high resistance wire is connected in series to the galvanometer, known as the multiplier. So, having done that, we will now know that the current, let's go ahead and solve. This place is okay, nothing there. We divide this into 2. Resistance of the galvanometer is already given to us as 2.5 ohms. The galvanometer and then the multiplier, let's call it M. The current passing through the galvanometer is, you can take 10 milliamperes, a very small current. 10 milliamperes, which if you convert ampere by 1,000, 0.01 amperes. Then the resistance of the multiplier is what you are going to look for. The current passing through the multiplier is the same current to pass through the multiplier and through the galvanometer, because the 2 instruments are in series. Then let the voltage across the galvanometer be Vg. Let the voltage across the multiplier be Vm. The total volt you want to measure is a voltage of 5 volts according to the equation. So that means we want to measure this. So we now have total voltage equal to Vg plus Vm. Having done that, our Vg, then move over to that side. Our V equal to, our Vg is IgRg, and our Vm is Im, but you know that Im and Ig are equal. We say IgRm. So the value of our V is 50, which is 5. Where the voltage we want to measure, equal to our Ig is 0.01. Our Rg is 2.5. Then plus our Ig remains 0.01 and Rm remains unknown. We multiply this out, 0.01 times 2.5. We do that. 0.01 times 2.5 will give us 0.025. 0.025 plus 0.01 Rm. Collect items, 5 minus 0.025 equal to 0.01 Rm. So 5 minus 0.025 will give us 4.975. Will give us equal to 0.01 Rm. Then the result of the multiplier becomes 4.975 all over 0.01. To solve, we have 497.5 ohms, a very high resistance, because that's the multiplier, and we need a high resistance multiplier to convert a galvanometer to a voltmeter by connecting the 2 equipments in series. So with this, you can try some other problems. It's a very simple task. You don't do it by groundwork. You understand the concept involved in doing it. So we always stay connected to Best Science Brain YouTube, and if you're not subscribed yet, get subscribed for more tutorials on chemistry, physics, and